In the year 1978, a pivotal moment transpired in the world of aviation. The industry behemoth Boeing Commercial Airplanes received its first orders for what would later become a revolutionary aircraft, the Boeing 757. Originally named 7N7, this twinjet would emerge as the successor for the widely used 727, setting new standards in aviation and forever changing the landscape of air travel. The design and development process of the Boeing 757 began in earnest during the mid-70s. The objective was clear: produce a worthy successor to the triple-engine 727, a popular narrow-body jet airliner that was proving to be increasingly insufficient in terms of fuel efficiency, noise output, and operational costs. The company initiated the 7N7 program to meet these needs, looking to build a more efficient, quieter, and economical aircraft. The 727's reputation was formidable, given its wide acceptance in both commercial and cargo transportation. Its tri-jet configuration had ensured a blend of power, range, and operational capability that had defined air travel in the 60s and 70s. However, the increasing cost of aviation fuel and stricter noise pollution regulations had begun to highlight the aircraft's shortcomings. The 7N7, later renamed the 757, was born from this necessity for change. The 757 was conceived as a twinjet, a significant departure from the 727's tri-jet design. Powering the aircraft were two high bypass ratio turbofan engines, either Rolls-Royce RB 211 or Pratt & Whitney PW 2000, depending on customer preference. This twin-engine configuration offered considerable advantages in terms of fuel efficiency and maintenance costs, setting a new standard for mid-range airliners. The 757 had a typical two-class seating arrangement for 202 passengers. However, in a high-density configuration, it could accommodate as many as 239 passengers, providing airlines with greater flexibility in their operations. In terms of aerodynamics, the 757 featured a supercritical wing design with a wingspan of nearly 38 meters, contributing to greater fuel efficiency. The aircraft's total length stood at 47.32 meters, and it had a maximum takeoff weight of approximately 115,670 kilograms. It also had a range of 4,700 kilometers, allowing for transcontinental flights across the United States or inter-European routes. The maximum cruising speed was Mach 0.80, striking an effective balance between speed and fuel efficiency. A key differentiator of the Boeing 757 was its advanced avionics. It incorporated a state-of-the-art digital flight deck that featured 6 Rockwell Collins CRT screens for flight instrumentation, engine data, and system information. This leap in technology reduced pilot workload and increased situational awareness, a crucial factor for aviation safety. In addition, the 757 was among the first commercial aircraft to utilize an electronic flight instrument system, or EFIS, which further streamlined cockpit operations. The introduction of a two-crew glass cockpit eliminated the need for a flight engineer, a significant factor in reducing operating costs for airlines. On the 19th of February in the year 1982, the first prototype of the Boeing 757 took to the skies. With a meticulous and intense test program that followed, the Boeing team and the aircraft itself were put through their paces. Safety, performance, and efficiency were rigorously assessed to ensure the new aircraft met both the manufacturer's and regulatory standards. Finally, the moment of truth arrived on the 21st of December, 1982. The Boeing 757 received its Federal Aviation Administration FAA certification, marking the culmination of years of effort and innovation. This certification was a testimony to the aircraft's design and technological advances, paving the way for it to enter into service and revolutionize air travel. One aspect of the Boeing 757's legacy that has raised some eyebrows in aviation circles revolves around its wake turbulence. Wake turbulence is a disruption in the atmosphere that forms behind an aircraft as it passes through the air. It is essentially the turbulent air left behind by the aircraft, caused by the wingtip vortices generated as the airplane generates lifts. For the Boeing 757, the wake turbulence phenomenon has been a bit peculiar. Despite being a narrow-body aircraft, it has been known to produce wake turbulence similar to that of significantly larger wide-body aircraft. This characteristic has led to the 757 being classified in the same category as wide-body jets for air traffic control separation standards. When the 757 first entered into service, it was placed in the same category as other narrow-body aircraft such as the Boeing 737 and the Airbus A320. However, incidents began to emerge where smaller aircraft following a 757 experienced upset conditions due to the larger-than-expected wake turbulence. In one such incident in 1993, a private jet flipped over and crashed after getting caught in the wake turbulence of a 757. In the wake of these events, the Federal Aviation Administration took the step of reclassifying the 757, advising air traffic control to apply larger separation distances when following a 757, akin to those used for much larger aircraft. The science behind the 757's pronounced wake turbulence relates to its design and performance characteristics. The 757's high-lift wings generate a significant amount of lift, leading to powerful wingtip vortices. The aircraft's typical cruise speed and climb rate also contribute to the creation of strong vortices. These vortices are pairings of counter-rotating cylindrical regions of air. When a wing generates lift, air pressure differences above and below the wings cause the air to swirl around in a circular pattern at the wingtips, leading to these vortices. The vortices from a 757 were found to be particularly powerful, and they could linger in the air for several minutes, creating a hazard for aircraft flying into the vortices. In response to these wake turbulence issues, air traffic controllers were advised to apply the same separation for the 757 as they would for the larger 767. This meant a separation of 5 nautical miles for smaller aircraft following a 757, an increase from the typical 3 to 4 nautical miles used for most narrow-body aircraft. In addition, pilot training and awareness programs were intensified to address this issue. Pilots were trained on the effects of wake turbulence and advised to maintain extra separation when following a 757. While the wake turbulence of the 757 presented a unique challenge, it is a testament to the aviation industry's ability to adapt and respond to new issues. The industry's reaction to the 757's wake turbulence problem showcases its commitment to safety and its ability to take decisive action in the face of new data and incidents. While the Boeing 757 was indeed a technological marvel, it experienced a complex relationship with the aviation industry. The aircraft's unpopularity, as perceived by some, can be attributed to a combination of factors ranging from economic to operational nuances. One significant challenge faced by the 757 was its position in the market. While its capacity and range offered certain advantages, these same specifications also placed it uncomfortably close to both the larger Boeing 767 and the smaller 737, especially after the latter's next-generation models came into service. The similarities in passenger capacity and flight range between these models led to a saturated market, with many airlines favoring the versatility and lower operational costs of the 737 and the greater passenger capacity of the 767. The timing of the 757's entry into the market and evolving industry dynamics also played a part in its perceived unpopularity. The aircraft was designed during an era of high oil prices, and as such, it was built to be fuel efficient. However, as oil prices fell in the late 80s and early 90s, the urgency to replace less efficient models diminished. Furthermore, the 757 was designed with the regulated market in mind, where airlines often flew smaller planes more frequently. However, after the Airline Deregulation Act in the United States in 1978, airlines began consolidating flights into larger planes flown less frequently to maximize efficiency, a trend that didn't favor the 757's design philosophy. Lastly, with the rise of the hub-and-spoke model, where airlines funnel passengers from various origins into a hub airport and then distribute them to their final destinations, larger wide-body aircraft became more attractive options. They offered better cost-per-seat mile ratios, proving to be more economical for airlines operating in this system. When the 757 was introduced, it was one of the few aircraft that could handle long transatlantic flights as well as short-haul domestic routes. However, with the arrival of extended operations, ETOPS, certified twin-engine aircraft like the Boeing 777 and Airbus A330, the appeal of the 757's versatility began to fade. These new models were able to carry more passengers over longer distances with better fuel efficiency, further denting the 757's market position. While many factors contributed to some airlines' hesitation to invest in the 757, it's worth noting that Boeing did manufacture over 1,000 of these aircraft before ending production in 2004. By that time, the company was shifting its focus to more modern and fuel-efficient models like the 737 Next Generation and the newly introduced 787 Dreamliner. Despite facing a myriad of challenges during its operational life, the 757 played a crucial role in Boeing's history. Its design and performance characteristics set the stage for the next generation of twin-engine, narrow-body aircraft. Although its popularity may have waned due to changing market dynamics and economic factors, the 757's impact on the aviation industry is undeniable. With its innovative design, efficient engines, and advanced avionics, the Boeing 757 redefined what it meant to be a narrow-body airliner. Its superior efficiency and operational flexibility enabled airlines to open new routes, particularly on transatlantic crossings that were previously the domain of larger wide-body aircraft. Although production of the 757 ended in 2004, the impact of this groundbreaking aircraft continues to be felt. Many of these aircraft still fly today, a testament to their durability and the timeless nature of their design. From its conception as the 7N7 to its evolution into the 757, this aircraft stands as a monument to innovation, ambition, and the ever-evolving dream of flight. A marvel of engineering and an icon of the skies, the Boeing 757 story is one of transformation and triumph, a narrative that continues to inspire the aviation industry and all who look to the skies.